Hi to you all. Happy to be here presenting at ESBG. First, I want to congratulate all of you for the efforts you are putting in to make straw the construction material of the future. There is a lot of work in front of us that can only be tackled together. I'm Björn Kjerulf, the CEO of EcoCocon, a modular straw wall manufacturer. Most of you know us already, but here comes an update as to where we are now. 2 years ago, we moved headquarters from Lithuania to Slovakia. We have increased productivity to around 11,000 square meters per year and have now projects in 23 countries on 3 continents. We are additionally preparing a second production center in Slovakia with 20,000 square meters capacity. Our goal is still the same. We want to achieve local production in each market. Why straw? I think we all know the answers to this question, but we might have learned something new in the last year. We all experienced the huge price increase of wood and other building materials. Straw is abundant and rapidly renewable, and is now proving itself also to be a valid economic alternative. In fact, we might have been the only company not increasing the price of a building material. This was only possible because we use very little wood. We need to future-proof the construction industry. This is why we certified our panels for the Passive House standard years ago. Perceptions of people are changing. They care about the environment, their health and comfort. They want buildings that perform without having a negative impact. This is something straw builders can provide, and we should all be proud of it. I want to highlight 3 advantages of our system. First, our modular structure enables a flexible design approach. The precision and variability of the modules adapts to almost any geometry. Second, a clay plaster can be applied directly to the straw surface on the inside. And third, an integral part of the system is the use of an airtight yet diffusion open membrane on the outside of the modules. The membrane provides weather protection even during construction. In order to achieve the Passive House standard, a wood fiber or straw fiber board is mounted on top of the membrane. The wall can then be plastered or clad with a ventilated facade. As for the technical characteristics, I want to highlight 2 aspects that are often crucial when building with straw. Builders need to know how much time it will take and that they can rely on the estimated costs and precision of the construction. All of this is crucial for the future success of straw bale building. This is something only prefabrication can provide. Architects and builders alike look for certifications when designing their projects. We should expect that quality control and certificates will play a greater role in the future. After all, we want straw bale building to be accepted by the mainstream. Although we have all necessary certifications, there is no harmonized norm for walls built the way we do. It is therefore impossible to obtain CE marking that would otherwise simplify acceptance in different markets. There is work to be done here by the straw building community to get this right. Straw bale construction should not fail because of formalities. Let's look at the test we did earlier this year. We dared to put a straw wall directly in the fire chamber without covering it in any way with a plaster or a cladding. just as a bare wall. As you can see in the video, unlike wood, the straw does not burn, only the surface is charred. The silica naturally contained in the straw works perfectly as a fire retardant agent. After 40 minutes it was over, the fire burned its way through the straw wall on the top. In the top of the fire chamber there is about 20 Pascal overpressure, and after the airtight membrane made a hole got the hole on the outside, the fire naturally pushed its way through. We also did another test with the fire retardant diffusion open membrane Fassawall A2. The thin membrane is placed on top of the straw. Surprisingly, the fireproof membrane protected the straw very well. Even after 60 minutes, the membrane was still intact. The test was terminated after 90 minutes. We hope this will open up possibilities of using panels with standard ventilated facades without any additional wood fiber board. Our modular approach enables carpenters and small construction companies to use straw in a similar way as they use CLT or other prefabricated elements. This is hugely important because we are enabling existing professionals to use straw in construction without creating any additional competition. I'm also convinced that we can get many young people to become builders because building with blocks is quick, fun, and rewarding. I think that it is important in a time when we do not have enough craftsmen. We can attract them by providing them with a meaningful occupation. And now to the main argument, tackling climate change. Every year, 144 million tons of wheat straw residues are produced in the EU. 1/3 of this can be removed without degrading the soil. And if we use just 10% of this, that would correspond to 100 million square meters of wall surface built annually. Even after taking into account production and delivery over 1,500 kilometers, 8.3 million tons of carbon can be sequestrated annually. Well, if we are able to build that many square meters. We now have hundreds of projects all over Europe. This is a gym in the Netherlands. The goal set by the municipality of Venlo was to create an energy-neutral sports center, mainly made from cradle-to-cradle certified materials. The aim was to contribute to a healthy, pleasant and sustainable living environment. Well, don't we all want just that? With this short presentation, I introduced you to the future of construction. I hope many of you are now inspired to design and build passive house buildings with renewable materials. Why? Because it is already easy to do so today. Thank you so much for your attention.